Today we're going to take a look at the converse of the Pythagorean theorem. And with the Pythagorean theorem, remember we took a look and it was a squared plus b squared equals c squared. What this allows us to do is to classify our triangles, even if we're not given a picture of a triangle based upon our side length. What you want to make sure that you do is that c is always going to be the longest side. Okay, it's a huge key in this converse of the Pythagorean theorem. And if that is the case, when you take a squared plus b squared, if that is greater than c squared, it's acute. Okay, that means that the added side is bigger. Okay, the added side is bigger, you have an acute triangle. If your triangle has the same value, when you take a squared plus b squared equals c squared, the triangle is right. And if a squared plus b squared is smaller than c squared, the one side is bigger, it's obtuse. Now the reason I kind of mention it that way is 1 and obtuse go together. Obviously acute and added both start with A, so it gives us a little bit of an alliteration that hopefully will help you remember which way to set your triangle. Now sometimes the triangles are going to be given to you, and you still have to let C be the longest side, because a lot of times the pictures are going to be very, very close. So remember that C is the biggest number, so we want to start with that. Okay, so I'm going to take a look at 15 squared, and I'm going to compare that to 8 squared plus 13 squared. Okay, 15 squared is 225. 8 squared is 64. And 13 squared is 169. Okay, so I'm going to add 169 to 64, and that is going to give me 233. Okay, my added side is bigger, and since the added side is bigger, the triangle is an acute triangle. Okay, and that will help you if you're trying to identify whether the triangle is right, acute, or obtuse, especially ones that are very, very close. Okay, here's another example. This time C is 29. So I'm going to start with 29 squared. And I'm going to compare that to 20 squared and 21 squared because those are the two smaller numbers. When I take 20 squared plus 21 squared, I get 841. When I take 29 squared, I get 841. Both of those numbers are the same, so that tells me that my triangle is a right triangle. If the added side is bigger, it's acute. If the numbers come out to be the same, the triangle is right. And if the one side is bigger, the triangle is obtuse. And with your calculators now, you can take the 20 squared plus 21 squared and do those all at one shot to make sure that your things are correct. Here's another example. This one's kind of easy to see, but we're going to take 6 squared and 8 squared, and we're going to compare that to 12 squared. 12 squared is 144. Okay, 6 squared plus 8 squared. We type those into our calculator. It's 36 and 64, and that's going to give me 100. This time the one side is bigger. Okay, so that means that my triangle is obtuse. And this is going to apply whether you can see the triangles or not. Okay, even if you're given just a series of numbers, you'll be able to identify whether the triangles are right, acute, or obtuse. Okay, so you don't even need to see the triangle anymore to classify it. Here are a couple more examples. Okay, for letter B. Okay, we're going to take our biggest side, which is 10. We're going to let that be by itself. And we've got 9 squared plus 9 squared. 10 times 10 is 100. 9 squared plus 9 squared is 81. It's going to give me 162. My added side is bigger, so my triangle is acute. Okay, over here, what's C? Okay, we got 26. So we're going to take 26 squared. I'm going to compare that to 14 squared plus 22 squared. 26 squared is 676. When I take 14 squared plus 22 squared on my calculator, that's going to give me 680. Okay, my added side is bigger, so that tells me my triangle is acute. Any questions on that? Okay, here's one last example with the picture. Okay, we're going to compare our sides, and our sides are going to be C at 14, and my two sides I'm adding together are 7 squared and 11 squared. 14 squared is 196, 7 squared is 49, 11 squared is 121, so that gives me 170. My single side is bigger, the 1 is bigger, so the triangle is obtuse. Now, one of the things that is very important with this is one of the ways that when you're doing some kinds of construction works, things become very important as far as telling if your figures are right triangles or not. For example, when Mrs. Baker and myself moved into our house, one of the things we realized was we didn't have enough storage space, especially for our outdoor garden tools. We had a two-car garage, we had 2 cars in it, so there wasn't a lot of space beside that. So what we needed to do was build a barn. And when I built my barn, I made sure that my dimensions were such that I could determine if my barn was square by finding the side lengths. So when I took my barn, I made it 12 by 16 so I could measure my diagonal of 20 to make sure that I had a Pythagorean triple. Okay. Madeline's going to do something very similar. She makes a picture frame with a diagonal crosspiece attached to the back for support. Can you tell from the dimensions whether or not the corners of the frame are right angles? Well, again, you want to use your converse of Pythagorean theorem. So there's C. So we're going to check is 39 squared the same as 15 squared plus 36 squared. Okay, 39 squared is 1521. When I add 15 squared to 36 squared, I get 1521. Since both of those numbers are the same, do I have a right triangle? Absolutely. Any questions on that? All right, the last 3 examples are going to be problems where you don't have any pictures. And you want to, again, use C to be your biggest side. But the first thing it tells us is to decide whether the numbers can even represent the side lengths of a triangle. This is the triangle inequality. And what we want to do with this is we need to make sure that our 2 smaller sides add up to be bigger than our third. So if I take 12 plus 35, is that bigger than 37? Yep, we're good there. What about 22 plus 25? Yep, we're bigger than 40. What about 15 plus 17? This one here is not even a triangle. Because in order for you to create a triangle, the triangle inequality says the 2 smaller sides have to add up to be bigger than a third. So we're going to do the 2 problems that we can do, 12, 35, and 37. So we're going to take 12 squared plus 35 squared. We're going to compare it with 37 squared. Okay, so 12 squared plus 35 squared is 1369. 37 squared, 1369 as well. Okay, what kind of triangle do we have? Okay, we got a right triangle. Okay, what about number 2? Okay, for number 2, the 2 sides we're going to add together are 22 squared and 25 squared. We're going to compare that to 40 squared. 40 squared is 1600. If I take 22 squared plus 25 squared, I get 1109. Which is bigger? Okay, my single side, my 1. So that tells me that my triangle is an obtuse triangle. Are there any questions on those? Okay, at this point, we'll go ahead and stop the presentation, and you can begin work on the homework, which is your worksheet.